left-hand sums, right-hand sums. These are two methods on how to approximate the area under a curve. And hopefully at this point, you know that area under a velocity curve means the total distance traveled. So what we do is when given a curve, we first want to know how many rectangles do we want to break this curve up. And so n is going to be the number of rectangles. So you determine n, and n is usually given to you. So I might say, hey, break the curve up into 5 rectangles. Once you have broken the curve up to that specific number of rectangles, then your job is to determine the width of each rectangle. And they're all going to be the same width. All right, and the width can be found. So the width, okay, this is the symbol for the width. The width can be found by taking the right endpoint minus the left endpoint divided by the number of rectangle that you want, and that gives you the width. All right. Once you have found the width, then you're gonna go ahead and kind of number them off. So say if I wanted 10 rectangles, then I would start with my left endpoint. I'll call that t sub 0, t sub 1, t sub 2, t sub 3, all the way up to t sub 9, because I wanted 10 rectangles. The left-hand sum basically means that I am gonna approximate the area under the curve using rectangles starting at the first endpoint. So what you do is you measure the height of the first endpoint, and you draw a horizontal bar over, and then you connect that with the next endpoint, and then you repeat the process so that all your rectangles are below your curve. And so this would be what we refer to as an underestimate, because we're losing, we're below the true value. For a right-hand curve, for a right-hand sum, you basically do the same thing, but you're gonna be overestimating your total distance by using the right endpoint first, and then drawing a rectangle with that height, and then connecting that rectangle to the previous t. And then you're going to continue on that pattern, and by doing it using this pattern, you're going to see that all your rectangle will be above the curve, which means that when you approximate the area using those rectangles, you will be overestimating the true distance or the true area. All right. So if your curve is actually decreasing, then your left-hand approximation will be an overestimate, okay, and your right-hand approximation will actually be an underestimate, because your right-hand approximation will be below the curve. So you kind of have to determine whether or not your curve is increasing or decreasing before you can do an overestimate or an underestimate, depending on the problem. Let's take a look at example 3. The velocity in the table below is decreasing. So the velocity is decreasing. That means that the curve is going to be decreasing. Using 5 rectangles subdivision, approximate the total distance traveled. So what I did is I already made the time axis and the velocity axis for you, and I also plotted the point for you. These are the point plotted. Let's go ahead and find an upper estimate. So the first thing we're going to do is we're going to try to connect these and make it curvy. So make it a curve and make it decreasing. Okay. So try our best. Like that. All right. Now, An upper estimate, since our curve is decreasing, an upper estimate will be by approximating the distance using the left-hand sum. So use left-hand sum. To use the left-hand sum, what I'm going to do is I'm going to start at the left, and I'm going to draw my rectangle starting at the left. Okay. Now, the length is going to be, the length of my first rectangle will be 44 inch. So I'm going to draw the 44 inch over here. Okay. And I'll connect that to here. Now notice that my first rectangle is above the graph, above the curve. And then I'm going to repeat the same for the second guy. Over here, go down. Okay. The third guy over here. And the third guy starts at that point. Right here, go down, because that's the height. Okay. And that point, go down. That point, go down. Notice that my left hand approximation is an upper estimate because it's all the squares are above the curve, which means that if I add up all those areas, it would be more than what's under the curve. So what I'm going to do is I'm going to go, okay, so the first curve has a velocity of 40. The height is 44. So 44 times 2 is going to be 88. Okay. 42 times 2, okay, these are 42. 42 times 2 is going to be 84. 82 respectively, and then 80 because I'm looking at 40, and then 37 times 2 is gonna be 74. All right, so by adding these numbers together, I will get an upper estimate of the total distance. All right, the symbol that we use to express this value is, we could go like this, guys. The distance is equal to, okay. Remember, because you have a subdivision of 5, perhaps we can start off by finding the width of each rectangle by dividing that by 5, knowing that the width, knowing that the endpoint is 12 and 2, we know that the width are 2, which we know that also knew that by looking at the graph. So the distance, or the area, so let's use the word area. The area is found by taking the width times, so the width, which is 2, right, times the length. And the length can be expressed as f at, or in this case, v at 2. That's the length. All right, plus the change in x times v at 4, plus the change in x times v at 6, plus the change in x times v at 8, plus the change in x, I'm sorry, it was this one, this is the last one, the change in x times v at 10, which gives us this rectangle. Now, one important thing I want you to know and remember is, when we use the left-hand rule, we tend to leave out this last value right here. So area is, we can summarize this, because each one of these terms has the change in x. Pull that out, and it's basically v of 2 plus v of 4 plus v of 6 plus v of 8 plus v of 10, which equals to 2 times v of 2 is 44, v of 4 is 42, V of 6 is 41. V of 8 is 40. And then V of 10 is 37. Add those together and double it. And that's exactly what we did. So 44 plus 42 plus 41 plus 40 plus 37. And then multiply that by 2. 204 times 2. That gives me 408. Okay. So the distance travel from 2 to 12 seconds, given the velocity, it's a little bit less than 408 because we're upper estimating. Now, same thing to this problem, but we're going to try to do a low estimation. I'm going to start by once again trying to draw this curve. Okay. All right. Now, a lower estimate means that we want our rectangles to be below the curve, which means that we have to use a right-hand approximation. So start off with the right endpoint. Okay. Draw the rectangle with that height to the next endpoint. Okay. And then here is the next endpoint. Draw the rectangles just like this. Okay, and here's the next endpoint. Notice that all these rectangles are below your curve, and therefore you are doing a lower estimate. In other words, the area of all these strips of rectangle will be less than the true area below the curve. Now I'm going to use the formula that I established for you. Area is, remember that we're taking the change in x, which is, let me once again write that, the change in x times, for a right-hand approximation, basically you're leaving out the last guy, you're leaving out the first guy. So this first guy will be left out. So it's basically V of 12 plus V of 10 plus V of 8 plus V of 6 plus V of 4. Okay, and I left out the last guy, just like how I left out the 12th second when I was doing a left-hand approximation. So knowing that that's 2, I'm able to find the total distance travel by adding up all these V values and then multiply that by 2. So 35 plus 37 plus 40 plus 41 plus 42 times that by 2, and I get 390. All right. So here's what we know. We know that 408 is a little bit too much. 390 is a little bit, it's too low. So the true value must be somewhere in between. So one thing we can do is we can maybe add these up and divide it by 2 to get a closer value to the true distance travel. But this is a lower estimate, and this is an upper estimate. An underestimate, again, all the rectangles are above the graph. A lower estimate means that all the rectangles are below the curve, and depending on whether or not your curve is increasing or decreasing, upper estimate could be a left-hand sum or a right-hand sum. Okay, last two problems. Use the expression for the left and right sum and the table to complete the following. So we are given four rectangles. What is the width of each one of those, and what are these values? So what we do is we call this our A value. The first time is your A value, the last time is your B value, and we're just going to use this formula. So the change in the time or the width of each rectangle is found by taking B minus A divided by the number of rectangles that we want. B is 23, A is 15, and we want 4. So the width of each one of our rectangle is gonna be 2. Because 8 divided by 4 is 2. So the width are 2. What are T0, T1, T2, T3, and T4? Well, T0 is going to be your first time. So T0 is going to be 15. Okay. T1 is going to be the next time interval. And that's 2 seconds away from 15, so 17. T2 is going to be 2 seconds away from 17, which is 19. T3 is going to be 2 seconds away from T2, which is 21. T4 is going to be 2 seconds away from 21, which is 23, and it should be the last value, which is B value. All right, and so remember, we want 4 rectangles. Here's 1, 2, 3, and 4. What are ft sub t of 0, ft1, and so on and so forth? Well, ft of 0 in this case would be like ft of 0 is like ft of 15. And we know that ft of 15 is 10. Okay. Ft of 1 is like ft of 17, and we know that ft of 17 is 13. Ft of 2 is like f of 19, which is 18. Ft of 3, which is going to be 20. And then ft of 4, which is 23, and that's 30. All right. So it says find the left and the right sum using n equals to 4. So for the left sum, so area using left sum. All right. So here's the quick way, guys. It's the change in t, which is the width of each rectangle, times the height, which can be found by taking f of t sub 0 plus f t sub 1 plus f t sub 2 plus f t sub 3. Because we're doing it using the left, we're going to leave out t sub 4. All right? So this is 2 times f t sub 0. It's really f of 15, and we know that's 10. Similarly, that's 13, that's 18, that's 20. Add those together, multiply it by 2, 10 plus 13 plus 18 plus 20, times that by 2, I get 122. So 122 feet, maybe, or meters or centimeter, we don't know. Okay. Right hand, so area using right hand. So for right hand, you're using you're still doing the change of t times, but we leave out ft sub 0. So we start with ft sub 1. So ft sub 1 plus ft sub 2 plus ft sub 3 plus ft sub 4. And again, if you need to know why we left that out, watch the first video. The first video hopefully will kind of help explain that. We know that's 2 times, and then ft sub 1 was 13, ft sub 2 was 18, ft sub 3 is 20, ft sub 4 is 30. Add those together, multiply that by 2, so 50 plus 18 plus 13 times 2, you get 162. 162. That would be a right-hand approximation. Let's do the last one over here, which is number 5. At time t in seconds, your velocity is given by 1 plus t squared from 0 to 6. Okay, so this is the formula for the velocity from 0 to 6 seconds. And they want us to use a width of 2 to estimate the distance traveled during this time. So between 6 seconds, a width of 2 means that I'm going to have 3 rectangles. So I'm going to go ahead and draw it. Okay, so a width of 2. So here's a width of 2. And I'm going to find the upper and lower estimate. So a width of 2. Okay, so go ahead and just plot off points every 2 seconds. Okay, So if I were to do a upper estimate, let's do upper over here. If I were to do an upper estimate, I have to start at the right. In other words, I'm doing a right-hand approximation. So I'm going to go like this. I'm going to draw my rectangle starting at the right. So move that over. Okay. Drop it down to 4. And then go up to 4. And then move it over to 2. Drop it down. And then same thing. So this is an upper estimate because all my rectangles are above the curve. So I will write it like this. So the distance, which is the area, equals to the area, which is equal to the width times the time. So we are, remember that since we're doing a right-hand approximation, you're leaving out the first part. You're leaving out this first point because this rectangle has a width which is the same as f at 2. So you go f, or in this case v, I'm sorry, because we're using the v function. So v at 2 plus v at 4 plus v at 6. All right. The change in t is 2. Now, what is v at 2? V at 2 means you have to take 2 and plug it into the v function. So v at 2 is going to be 5. V at 4, 16 plus 1, 17. V at 6 means that 36 plus 1, which is 37. All right, add those together. So you got 37, 47, 57, 59 times 2, which gives us 118. So the distance, an upper estimate is 118. I would advise you to pause the video, do this problem first, and then do this part first to find a lower estimate, and then try to see if you get the same answers as I did. Alright, so I'm going to go ahead and plot these points again on the graph. 0, 2, 4, 6, because every 2 seconds. Because we're doing a low estimates, it has to be a left-hand sum. So I'm going to go ahead and draw my rectangle here. Okay. Draw my rectangle there. Okay. And then draw my rectangle there, and that would be a lower estimate. And so once again, my area or my distance, because area means distance now. So my area or distance is equal to my total area is by finding the area of these 3 rectangles, which we know that it's the change in t times f at 0. Okay, f at 0. I'm leaving out this term, this part right here for my left-hand sum, plus f at 2 plus f at 4. This is 2. F at 0 is found by plugging 0 into v. So f is your v. Plug 0 into v, I get 1. Plug 2 in for v, I get 5. Plug 4 in for v, I get 17. 23, 24, 2 times 24, which equals to 48. So 48 is my lower estimate for my distance. I will see you guys in class.